Hey everyone, welcome to the Cohort 4 of Feminine Ethereum protocol. And today we have Justin with us, and he will be taking the session on consensus specs and Ethereum security. So, Justin, can you take up and introduce yourself and start the session?
Yeah, of course. Hello, everyone. I am a security researcher at the Ethereum Foundation. I've been with the foundation for about 4 years now. Previously, I worked at a big organization in the United States doing vulnerability research. Yeah, since I've been at the EF, I've taken on several different responsibilities. One is reviewing clients, primarily focusing on the consensus layer side of things. Along with that, I kind of became really familiar with the consensus specifications. So I became the lead maintainer of those about a year ago after Shawway became the co-executive director of the EF. I still do security things as well. And how should I say it? I've also done some cool things on the KZG libraries, which were important for blobs and Deneb. In this call, I don't have anything planned really, but I go over the specifications, give it like an overview, like how I'd start, and try to answer any questions. And I'll also open up like a Visual Studio Code and kind of go over things as well, like how you build, test, etc. That's pretty much my introduction.
Yes, thank you. Thank you, Ken. Thank you very much.
Okay, sure. I'm going to share my screen just 1 second. All right. So yeah, these are the consensus specifications. This is what the consensus layer clients implement for Ethereum. There are about 5 of them. I have them right here. So there's Lighthouse, Prism, Teku, Nimbus, Lodestar, and Grandine. These are all written in different languages, and they all have to implement the exact same thing. There can be like small changes, but for the most part, it's the exact same. And they all need to know what to implement. And that's where the specifications come into play. The specifications are all written in Python, which is exposed in Markdown files. I can show you that later. But it is a simple implementation, which is you cannot actually run it as a client, but it's simple enough that clients know what to implement and it's clear, and there's tons of tests. I'll start right here. We've been creating these since the very beginning of the Beacon chain, and that was like 2020, I believe, or maybe end of 2019. And that started with phase 0. I wish it had a better name, but it was just phase 0. And then for each fork, there's a different specification, which is built on top of the previous one. So like Altair, Bellatrix, Capella, Deneb, Electra. We're currently about to upgrade Fulu, which is planned, somewhat scheduled to happen at the beginning of December. And then there's Gloss, which is the one that'll happen afterwards. Spec development is sort of a pipelined process. So like as we're working on the specs for Fulu and trying to finalize that and make sure that it's all secure and ready and implemented, there are other researchers and developers working on the implementations and specs for Gloss, which makes it kind of crazy at times, but it's fun. This repository also contains the specifications for SSD, which is called Simple Serialize. And this is the encoding format, which pretty much all the consensus layer clients use for compression. Yeah, I guess it's just compression, but yeah, it's very nice. And then also the Merkle proof formats, but we don't really worry about these too much. They don't change very often. There are some external specifications, but we don't really need to go over those as well. A notable one, in my opinion, is the builder specifications, which relates to like MEV boost and commit boost, if you're familiar at all with those. I'll skip over this for now. And I guess I can talk about the design goals some. I kind of mentioned it before, but the goal of the consensus specifications is to pretty much minimize complexity and make it as clear as possible what is going on. And then another big goal is to pretty much, how should I say it, like remain live through major network partitions, meaning that like the goal of the network is to stay up. Like I think Ethereum has a really great track record of this, of like never actually going down, unlike some other chains. And that is a goal and something that we have to keep in mind when writing specifications, because we want them to be pretty much as hardened as possible. We need to think of all the edge cases, etc. I would like to discuss some of the useful resources that you might use when beginning to work on the consensus specs. Actually, I'll start with this. So this is the specifications from the point of view, or not, how should I say it, in a more readable way. So you can kind of click on specs, phase 0, beacon chain, which is I guess what we're already at. and read it in like a really nice, pretty markdown format. The specifications for phase 0 are quite a lot because we have to be pretty much as specific as possible. I should say, but pretty much everything is defined, all types, containers, functions, like how things are expected to work, etc., is all here. And then I might need to find it, but there is a consensus. I don't know how I'd actually find it. It might be on his repository. Here it is. So it's the annotated spec by Vitalik. I found this particularly useful when first starting at VEF. The specs themselves are not exactly like beginner friendly, which can kind of make it difficult to really understand what is going on. And I found this repository to be especially helpful. Pretty much he will go over the specifications in like a human readable manner and kind of explain like why exactly we made these decisions. Let me see if I can find an example. You can sort of tell that this is more just like paragraphs instead of code, which can be very useful. So here are the links to the consensus specifications themselves, the thing I'm primarily going to talk about today. This is a link to the annotated spec by Vitalik. Another great resource I'd like to share is the ETH2 book by Ben Eddington. He was a core dev, the project lead for a consensus layer client called Teku, if you've heard of it. I think he realized that like things weren't as clear or as easy to understand, so he wrote an entire book on it. It's only up to date for Capella, which I guess was a couple years ago, but most of the information on this website is still valid today and accurate. And it's really nice because you can search as well. You can say like slashings. I guess you'd have to like click on it. Then you can like find an exact paragraph and you can just like jump right to it if there's something that you're like you decide that you want to know more about. What else is there? This isn't especially useful for beginners, but for client teams, there's another resource that I wrote for viewing all of the I should say like the code without having to click between multiple files. So you can say like blob, and it shows you everything that's associated with blobs for each different fork as well. Let me see if I can find an example. So for example, blobs bundle in Fulu is this, whereas in Deneb it's this. And that makes it particularly useful for them to view differences in specifications. And I guess that's about it for the overview. I guess I can kind of explain where things are located in this specs repo a bit. The most important thing, I guess, would just be the specifications themselves, which are located in the specs directory. And then in the specs directory, the name of each subdirectory is the fork name. So for example, like Altair, Bellatrix, Capella. I'll click on phase 0 since it was the first one. In this directory, we split the specifications into multiple files depending on which component they're kind of associated with. Beacon chain is probably the largest and probably most important. This is the bulk of what the consensus layer clients have to implement to pretty much follow the chain and to like for a full node. If you guys are familiar with what that is, it's like the thing that anyone can run. Doesn't cost any money. You just have to have a computer and you run this piece of software and it validates the chain or doesn't validate the chain. What am I trying to say? It tracks the chain, but it doesn't send attestations or anything. And you can use it to like watch transactions and stuff like that. The deposit contract, this was like a one-time thing and it doesn't get mentioned in any of the other specifications, but this is the smart contract that Ethereum validators send money to in order to become a validator. And a validator itself is actually, do you guys know what a validator is? Or I should probably just explain it anyway, safe to assume, okay. A validator is it's an Ethereum node which has put up some amount of money. In this case, the minimum is 32 ETH tokens. And that pretty much grants it the ability to attest and to earn rewards and to propose blocks and to pretty much, it's like an additional responsibility. I don't know how to say it, but it's responsible for pretty much validating that the transactions are correct, validating that this proposal is valid, and for proposing blocks. You can be slashed if you behave incorrectly, I should say, or actually incorrectly is the wrong word. You can make mistakes, but if you're malicious, you might be slashed, and that means that you would lose some portion of the stake and then be exited as a validator. So you're pretty much kicked out of the group. Then there's a document on fork choice. This is almost above me in a way, but this is like, it explains, sorry, how do I say it? It explains how clients should implement their decision making for when there's competing chains, essentially. Like, say, a validator proposes block A, and then half the clients disagree with that and say that it's invalid. And then the other 50% agree. Like, what do you do? Like, how does that work? It can get kind of complicated. No sense in going over that right now. The next document would be the P2P interface. This is peer-to-peer, and this is essentially how the nodes and validators communicate with each other. The whole network is set up in kind of like a mesh network in a way, like where one node will have between like 50 or 100 or maybe even more peers. And a peer is just like a friend on the network that you can talk to. You can ask the friend, the peer, like, do you have this block? And can you send me all this information? Like, do you see this? I see this. Here's some more information. And that itself has to be quite robust as well, because sometimes there could be like a malicious friend who wants to take advantage and to like bring you down. And then there's the validator specifications. And this is like sort of built on top of the beacon chain, I would say, specifications. These are like the extra responsibilities that a validator needs to implement, or that a node needs to implement in order to become a validator. This includes things like how to submit a block, how to participate in a sync committee, how to attest, and stuff like that, the additional responsibilities. And then there's the weak subjectivity documentation. You don't really have to worry about that. That's very specific and small. I'll start with the beacon chain specs just to kind of give you a sense of what these look like. We define configuration values, containers, what else? Helper functions, which are also important. How to deal with the genesis. So this is like the first block in the entire network. Like, how do we all agree on what's the first thing? And then, oh my gosh, yeah, the state transition functions, which pretty much say like, once you receive some new piece of data, like, how does the state progress? And the state is essentially like a snapshot at a point in time of the Ethereum blockchain. Like, what is the latest source of truth, I should say. There's so much to talk about. If you're not familiar with an epoch, I should probably go over like what the consensus layer is itself. Every 12 seconds, a proposer will submit a block, and then the other validators will attest to said block. There are 32 slots per epoch. An epoch is just like, well, the word existed before, but it's just a unit of time. In this case, it's 6.4 minutes. I don't know how to say. Epochs can be finalized or justified or unfinalized. Typically, it takes, I think, 2 epochs for an epoch to become finalized. And that pretty much just means that there's no going back. Like, after an epoch has been finalized, it's like set in stone. You would have to slash a very large percentage of the network, or slash a very large percent of the validators in the network to go back. And that would be probably billions of dollars. It's pretty important. And then there's block processing. Yeah, but everything is in Markdown, which can kind of make it easier for beginners to read and to like reason about. It's not just like code, which I particularly like. We take all of these Markdown files and we compile them into code, just like Python code. But that's a bit, how should I say, like abstracted away. Like, you don't really have to worry about that so much when dealing with the specifications, which is really nice. Yeah, a lot of this won't make sense without studying it or without me really explaining it. I guess the important part is to know that like the specifications define everything that's important for clients to implement. Let's see what else there is. Okay, I will talk about how forks work, I guess. Yo, what's up?
Hey, Justin. Sorry, I just wanted to cut you. I don't know. We have some questions in the chat. Would you like to go with the questions as it comes, or when you round up?
Yeah, I can. Let's say block header.
Okay. Yeah. So the question is, I would really want to know about block headers.
Sure. I mean, a block header is just the shared information for a block. It's like this, like a small portion that's included at the top without all the actual block data. So it's just like metadata, I suppose. The slot. So like for each block, there's a slot. You can only have one block per slot. That's where that comes in. the actual validator which proposes this block is stored here. The block of the previous, or sorry, the root, meaning like it's like a hash. You can think of it as like a signature in a way of the previous block is also stored there. So that's what kind of makes this a block chain. So you have the parent and then that, and they all link together and you keep going and it's just one big chain. And then it also includes the like root of the estate and then the root of the body. And I guess the body root is useful because the beacon block itself, which I don't know where that's defined, but you need to ensure that the header matches the actual data, if that answers your question. The beacon block itself, let me see if I can find that. So here's the body. It contains important stuff, but like the Randall reveal, the graffiti, which is the thing that you'll see like when a proposer submits a block that they can provide like a 32 byte, it's a pretty short string of information. I don't actually know why this was introduced or like why this was necessary, but it is kind of cool that you can say like Ethereum rocks or something and have that pretty much visible forever. Proposer slashings, attester slashings. So like if a validator does something wrong, this is where these will show up. It's a responsibility of other validators or nodes. I think it's validators. If they see that another validator does something wrong, they will share that with their friends, the peers, and then it will be included in a block so that it's pretty much like set in stone forever. And it's like proven that this validator did something wrong. And then I don't really need to talk about deposits or voluntary exits. And then here's the beacon block itself, which contains, I guess, just the block body and some other header information. So the only difference between beacon block and beacon block header is that body is this type, whereas in the header, it would be the body root. Yeah. I mean, there's so many different containers and classes in here. It would take me probably a week to go over all of them. And it would probably take you just as long to learn about them. But I promise it's not actually as difficult or as complex as it seems. Like all of I mean, except for maybe some of the crypto stuff, that's, even I don't understand that. But yeah, I don't know how to say it, like some things might not make sense at first. And like maybe after like some time, it'll finally click and be like, oh, so that's why they did it that way. Or like there was some, I don't know how to say it, like, yeah, some vulnerability that they didn't want to, they wanted to handle. Okay. To answer your other question, so epoch is the amount slashed if it is not finalized. Not quite. Epoch is just like a clock in a way. It's like, what's the latest time? Like how many, it's not seconds, but you can think of it as like how many seconds since the beginning of time. In that case, the beginning of time is Genesis, which would be 0. So I could probably do beacon chain. This is an excellent block explorer and it kind of shows you right here. So like we're currently almost at epoch 4,000 and, or sorry, not 4,000, 400,000. And the current slot is 12,766,000. If you divide this by 32, it will equal this number or one of these numbers. And there are currently over 1 million active validators as well. And epoch kind of looks like this. So you can see that, I don't know why it refreshed. So every 6.4 minutes is it finalized. That's what this column is for. And then this is sort of the percentage of validators that voted in favor of, well, this whole epoch in a way, in a sense. And if you click on a specific one, let's see what it shows. So yeah, you can see more information. Like for example, this is the exact amount of ETH that voted in favor of this epoch. And it will actually show you the exact, or sorry, all of the slots in that epoch, if that's important as well. It's all very precise and cool. Let's see. I'll go back. It doesn't happen that often, maybe less than 1% of time, 1% of the time, but sometimes there will be a missed slot or like a missed proposal. And that would just show up as like missed right here. Those happen generally because a validator is like offline because the operator is updating it or whatever. But yeah, and that's okay as well. To become finalized, for an epoch to become finalized, I think it's like 66.666% of validators have to attest in favor of that epoch. And that's just to I forget why exactly it's not 51, but 66 2/3 is the majority that the beacon chain uses. So yeah, I'll go on to the next question. I'd like to talk more about the P2P interface and how it affects the beacon chain and forks. Sure, I know what to say. I'll start with this thing. So there are these things called, actually, how should I say it? We have this protocol, which we call gossip, and I don't know who named it, but I like the name. It's pretty much just like a way of saying that you heard that there was a block and then you share it with all your friends. But there's checks involved with this. You would receive a block from a friend. You would check that it's correct and that it matches your understanding of the current state of things. And then if all the checks pass, you share it with like your other 100 friends. And that way it propagates over the entire network pretty quickly. And there are different gossip topics. That's like the word here. So like the one I'm looking at right now is for beacon blocks. It's like this is the essentially group chat in which you would share a new beacon block and then talk about it with your friends. And then there's like one for aggregate and proofs, which is like some other type for voluntary exits for like when a validator wants to leave the network, slashings, and then attestations, which are probably, well, I don't know if it's the most important, but there are lots of attestations. Tons of checks, and this looks like a lot. This actually is kind of a lot. All of the rejections and ignore statements. Yeah, this is actually a pretty common point of issue, or I should say, like if a client makes a mistake, it might be here. But how it affects the beacon chain and forks. Let's see, when a client or when the network forks, just say it. Sometimes there are new like gossip topics. So essentially, they will create a new group chat for an updated container, or like say the beacon block changes formats, you would create pretty much an entirely new topic, a group, and then you would start communicating over that one instead of the old one. And that's sort of just how it works here. It's fairly simple. Did that answer your question, Alienate? Or is there anything else you'd like to know?
I think you've covered out everything, and it's going to set me up to learn more as I continue.
Okay, great, thank you. Okay, the next question is, how does this translate or connect to the ABI? Or perhaps ABI is purely smart contract data and nothing to do with blocks? Yeah, I think it's probably the not much to do with blocks. Like it's more execution layer side of things. Like the consensus layer, how should I say it? Like the execution payload and the block itself are almost abstracted away. Like we don't really care what's inside of the execution payload. Yeah, pretty much just, is it valid or is it not valid? That's pretty much it. So I don't exactly know how it relates to the ABI. Okay. There's another question. Specs are updated as EIP is confirmed for the next protocol update. Yeah, that's correct. And clients start implementing after consensus specs release for the update. You would think that, but sometimes the clients will implement before the specs are ready. It's sort of like a chicken and egg problem. Like you don't really know how to write the specs without writing part of the implementation first. So typically clients will try to like prototype some change. What is it? Okay, I'll continue. Sorry. Clients will sometimes implement like a proof of concept in their own client first, and then they'll like, okay, this might work. We could maybe write some specs for this, make an EIP for it, etc. But generally the specs are released before multiple clients start to implement it. So for the gloss, which is the fork after the next one, we just released the first version of the specs with the glass implementation inside of it. And all the clients are just now beginning to implement that for the first DevNet. Now, DevNet is just like a very temporary network where we develop on, just to make sure, just like figure out bugs and just to make sure it all works. But this is a good question, and I can show you where the EIPs exist. So in the specs, and then there's this directory called features. We should probably just rename it to EIPs, honestly. And this is where each of the EIPs are implemented. I will pick 7805. This is for Fossil, if you've heard of that or not. It's like the fork choice inclusion list. I forget what the exact implementation, I forget what the exact name is, but fork choice enforced committee-based inclusion list. It's a mouthful. If I recall correctly, yeah, these specifications are built on top of the Fulu specs. So this just contains what has changed. What changes do you need to make to the Fulu specs in order for this feature to be implemented? Generally, it's pretty simple. So like we'll introduce some new type, in this case, an inclusion list, and then the helper functions, which are necessary. So like, is this a valid inclusion list? And then all the checks. If and when this EIP is, I think it's scheduled for inclusion or confirmed for inclusion or whatever the word is, when the community agrees upon a specific EIP, we will then merge these specs into the named fork specs. So concretely, if we agree to include 7805 into GLOS, we would merge all of these specs into these files right here. And I would be responsible for doing that. No one else has to worry about that. It's not actually that hard. It's just like squeezing or like just merging files. Let's see. I'll just mention the fact that we do it this way so that clients can sort of implement this exact feature without having to worry about a bunch of different changes in other EIPs. Like, I don't know exactly how to say it, but it's easier to implement just one thing than it is to implement 3 things, which are constantly in motion. And then once we prove that it works and that it's ready, we merge and then we start testing together, like with integration testing. Okay, I'm going to move on to the next question. If it happens that an attestation isn't added to the block, what is the likely causes? How can it be debugged? Do you have any recommendations also to read up about that? So yeah, this is actually pretty frequent, or this happens pretty frequently where an attestation is not included in a block. Typically that happens because someone's internet isn't quite as fast and they weren't able to share that attestation quickly enough with their peers, or the block was very large and they didn't know, like they couldn't check it in time and they sent it late and the network didn't get it like in time for the proposer of the next block to agree on it. So say you submit an attestation that's like, actually, I should say that attestations, I believe, are due, it's like 4 or 8 seconds into the block. So you have a limited time period in which you can submit an attestation. And yeah, that might actually be reduced in the future, so it might happen more often. How can it be debugged? It's a good question. Typically, you would check the console or like the logs for the client that you're running, and just to see if like, did you submit an attestation in the first place? At what time did you submit an attestation? And if it's like, if you submitted it well in advance and the network should have accepted it, you might have to look into it more. I'm not exactly sure how you do that. It might have been like an invalid attestation, or you encoded it improperly, in which case you would have to like check on different systems, see like why did they reject said attestation. Do you have any recommendations how to read up on that? Almost certainly, I would recommend ETH2 book. I'm sure they have written like many pages on attestations. Let's see if I can find one. I feel like there should be a very simple second. Yeah, Rohima, what's your question?
I think you missed my question in the chat box. I was asking.
Oh, it's next, but yeah, go ahead.
Oh, okay. So I was asking about the resources you shared, like how we can learn, because there are a lot of resources and it can feel overwhelming when you try to like approach, you don't know which one to go first, how to even begin. So what path do you think, or do you suggest a beginner should follow? Where can we start from? And it would be nice for you to share your journey, like how you got to your level of expertise today.
Yeah, sure. I'll try to find a link to the more about attestations later, by the way. It'll take me a minute. You're totally right that this is definitely 100% overwhelming. I don't think I felt comfortable at all with this for probably like at least a year, which is kind of wild. How I started was just chatting with friends, I would say. I was recruited from an old coworker, and he kind of explained to me like what Ethereum was and why it's cool and etc. Of course, he didn't tell me everything about it, but I did have a general idea of like what Ethereum was. And I guess the first place I started was the annotated specifications from Vitalik. I think this is what really just got me to understand it, or like helped me understand it the best. I would recommend just reading starting at phase 0, beacon chain.md, starting from like this part of the introduction. It'll go over some of the things that I've already said, but like in a much clearer and like better way. Like, what is the consensus layer? How does it work? ETH2 is an old name. You can ignore that. Even this might seem complicated, but this is what I did. And then I just took notes and pretty much wrote down everything, wrote down all my questions, and then I would try to follow up with someone that knew more later. Mercy, what's up? Or what's your question?
Yeah, so I have a question. My question is about the full spec, right? So how does this full spec guarantee that all validator sample sufficiency drive the diversity columns to prevent correlated blind spots? Is there like a minimum entropy requirement encoded, or it's just left as a networking layer assumption?
Can you repeat the beginning of that? What is the
Okay, I said, how does the full spec guarantee that all validator sample the sufficiently diverse columns to prevent correlated blind spots?
That's a good question. I'll have to find it. To be fair, we don't sample everything, and there might actually be blind spots. If I recall correctly, like a node will only sample, I think, 8 datacom sidecars from peers. And if the whole network does that, it's enough to pretty much ensure that that data is present. It's one of the nice tricks you can do to like download less data but still have the same data availability guarantees. Where this is, I don't recall. I'll have to look around for a minute. It'll be under sampling, wherever that is. It's not there. STD sampling. So there's no guarantee that there won't be blind spots. Like there might be. How many samples you do, like how many samples a node does, is based on how much it has at stake. It's like, I think a regular node without any at stake will, I think a sample is 4 or 8. I don't recall exactly, but if you have more at stake, you'll sample more. And that's kind of like I think if you're this thing called a supernode, you might sample like everything because you're going to download literally everything. And that's I guess that does work in a way to like prevent blind spots, because those supernodes will, if there's something missing, they will say like, oh, this is missing. And then they will reconstruct that data and then gossip it out some more. And like, it would only be unable to do that if, I think it's like 51% of the data was unavailable, in which case probably lots of other nodes would say like, hey, I don't have this data, like something's missing. But also the supernode would be like, I don't have this data, I can't reconstruct it. Like, there's nothing I can do. Like, this is unavailable. So
Okay. Sorry.
Did that answer your question?
One last question. Yeah, it does. Then I have another question on that. So now looking at the fork choice with the LMD ghosts, so it depends on block availability and attestation, right? So with peer DES affecting when data is considered available, are there updates to the fork choice conditions or scoring logic in fully spec? Is there an update on that? Would there be an update on the spec?
An obvious what exactly?
I said like since peer DES affects when data is considered available, are there updates to the fork choice conditions or scoring logic in the spec, fully spec?
The only update I would say is this is data available function in fork choice. And it kind of talks about what we just talked about. But besides this, I'd say there's no scoring changes. Like it'll still work the same, LMD ghost.
Okay, that's all.
I mean, there's also the changes to unblock, but the only modification is data available again. So I forget where that is. It's right here. So in the specs, we also include this, like, I like to call it like a fork comment, and it shows you what exactly has changed or like where the change is. I'll keep going on the resources to learn a lot. Like it is overwhelming. My journey's still been, how should I say it? What did I do? So after somewhat becoming familiar with the specifications, I begun reviewing Teku, which is the consensus layer client written in Java. I felt that was very helpful for myself. I was pretty much able to read, like compare the specs to an actual client implementation and see like what they do differently, what they do the same, which like optimizations they make or assumptions, or like sometimes it's wildly different than what the actual specs do. That was very enlightening in a way. What else? Really it just takes time. I don't know. There's no shortcuts, unfortunately. I might try to use like more ChatGPT and stuff today, but even that, I don't know if it would be entirely accurate. Like I really likes to hallucinate. But for the basic stuff, I think it might be a good resource if you say like, what is an epoch, or like how does the validator lifecycle work, stuff like that. I think it might be able to explain it quite well, but I would keep in mind that it could be wrong. Take everything it says with a grain of salt. Yeah, I would recommend starting with the annotated spec. That's probably the most readable. And then based on questions that you have from, sorry, this thing is covering my tabs. Based on questions that you have there, I might try to search the ETH2 book, which I did share. It might be able to explain it better. Like I found the answers there. And yeah, thank you, Mercy, for sharing the link. Yeah. And then only after that, probably would I like really go deep on the consensus specs, like in this directory or this organization or repo, unless you're just making like a small change because something is very clearly wrong. That's easy. Let's see what's the next question. Are gossip entries like ETH research conversations? Not exactly, no. I was probably explaining it a bit too high level. It's very low level, like network packets. Yeah, just like the specific piece of data, like here it is. And like, yeah, it would be like sending an image to a friend, per se, or like, I don't know how to say it, but yeah. And the specs for the next update are only the differences from the previous update included. Yes. And that is something that might take a little while to get used to. Everything is built on top of each other. Only includes the changes. Actually, I'll look at Fulu. It's probably a little bit simpler. So like compared to the phase 0 specifications, this is very small. That reminds me of like other advice. You can start by learning phase 0 specifications, but it's not always necessary. Like you could just start with Fulu. So like familiarize yourself with Fulu, the thing that's about to be upgraded, and then you can kind of work backwards as well. I think I did that. When I first joined, we were about to do the merge, so Bellatrix, and I definitely focused on the Bellatrix specifications first, like after familiarizing myself somewhat. And just because they're like a lot smaller, it's easier to manage. You just kind of like look at what's changed and what's new. Okay, another good question. It was mentioned that the Markdown files are compiled into Python. Why is that? That's because we need to be able to execute them to generate the spec tests. And I can probably go over that some now. Let me share my other screen. So yeah, executable specifications, all the Python is extracted from the Markdown files and put into like this one really big Python file. And then you can essentially generate test cases, run the test cases, save the outputs, and then give those outputs to the clients to use as reference tests. I can kind of show you here. You would do like make test to test it locally, and then you would do make ref tests to generate the reference test, which the clients use. There is something called make iSpec, but it's hidden. And this essentially sets up an environment that you can build everything, downloads a bunch of dependencies, and then builds the files. I can try to show you what that looks like. I don't know if I'll be able to find it. 1 second, it'd be like that. So this is what this looks like. You don't have to worry about it. Like this is it's hidden pretty well. But just literally all of the code goes into a single file. I can probably scroll even faster. It's a lot. All the functions, everything, yeah. And then when you execute a test case, actually, let me go over that really quickly too. And I won't have that much time. I'm sorry. Test cases would be in the tests, core PySpec, ETH2 spec, test directory. This looks like it's all organized in different files based on like what you want to do. It looks like this. We define test cases with Fulu and later. It's a spec test name, do the thing. If you were to copy and paste this, you could do make test, in this case, K equals the name. K is just shorthand for like name. You don't want something too long. It takes a second to compile, and then it takes a second to start the test. Nothing is exactly fast. While this is running, I can tell you that it takes like 6 hours to generate all the reference tests that the clients use. And yeah, that's what this looks like. So it ran that one specific test and it passed. You could run all the tests for, actually, verbose equal true. Use this command if you're like getting started with the repo. But what I was trying to show you is that you can do make test by itself to run everything. You can do make test specific test. You can do make test a specific fork, a specific preset, which is either mainnet or minimal. Minimal is just a lot faster. and you could use them all together if you wanted to run like this very specific test for the specific fork. And that can be quite valuable. There's so much to talk about. Yeah, I'd probably need like a whole nother day to go over all of this. But you can get to the test real quick via, let me try to show you. The README links to the specs and the tests. On GitHub, you could just click this link. Here, I'll command click. Oh, that's weird. Oh, it just opened the directory, I see. And then inside this directory is all the tests for that specific fork. Pretty simple sometimes. Sometimes they're really long and complicated. If you ever open a PR, actually, let me get to the questions. Again, there are 3 good first issues, and if you ever open a PR, I would be happy to help you. This first good issue is actually a little bit more difficult. I would suggest doing 4618 as like a great first issue, and also maybe 4632 as another pretty simple issue. If you have any questions, just like comment on the issue itself, and I will respond as soon as possible and try to help as much as I can. If it feels like it's gonna be a lot, I could like share my Telegram, which is Traglia, and my Signal, which is jtraglia01. Feel free to comment. And my Discord is also jtraglia. Everything's jtraglia. Feel free to reach out to me. I can help you. I can also probably even come up with more good first issues. Yeah. It can definitely feel like a fire hose of information at first. We all know that. We all feel that. Yeah. Let me see what else. A technical handbook on Ethereum's move to proof of stake. Yep. The PDF. Yep. Those are great. How are the tests used? Yeah, the clients consume the tests, and it ensures that they implement everything properly, and it also helps identify bugs. Can they test them through the tests you provide in the specs? Yes, they can. And I can even say that we identify a new issue and we want to write a new spec test for that. I can generate that exact spec test and give it to all the clients, and they can test whether or not they're vulnerable to said issue. Will the issues be assigned, or you just send a PR for it? It depends. If you see that no one's taking it up and it's a quick thing, you could submit a PR and I'd happily review it without having assigned it to you. But if you want to like own it and it might take you a couple days, comment and I can assign it to you. And then you could have like a week or 2 to work on it. There's like no rush. What else? I guess that's, oh, I'm so sorry. I was showing my code screen and not the web browser. Oops, 1 second. Sorry about that. This was the list of good first issues. I was saying that the warnings when running tests and the fix error messages when controlling C might be a good issue to work on. But all of these are fine. Yeah, depends on whatever you're comfortable with. Yeah.
You notice all these good first issues are taken, the ones you're showing right now? None of them is open.
Yeah, really? Okay.
Yeah, because I see individuals have been assigned to them.
This one isn't assigned. Oh, actually it is assigned. I'll unassign this one. They have not been working on this.
Oh, please assign me that.
Could you please comment on the PR? And then I can only assign after.
Help me share the link on the chat so I can comment on it.
Yeah, of course. There you go.
Thank you.
Yeah. Okay, so there's another question. I noticed all the code in this repo is written in Python, so you have to be familiar with Python to work on it, right? Only partially. Like a lot of it's just like text and paragraphs, and I don't know how to say it. Like it's described in text rather than code. But if you do want to change like a spec, the actual spec function or a spec test, then yeah, it's pretty good to know Python. And I didn't think of that as like a prereq, but it is a prereq. Like for example, probably a lot. Well, like I guess a good example is the P2P interface. Like very little of this document is actually code. Yeah. What is a good first issue and open? I was just there. 1 second. There might not be enough good first issues for everyone, but I can work on more. But let me share a link to good first issues. This page that I just linked will contain good first issues. I can work on adding more of those when there's time. Yeah. I know there's probably not going to be like a ton of them at any point in time, but they just, whenever I think of something, I just try to make an issue for it. I don't feel like I was able to like really go deep into this, but I hope that what I said today was useful for everyone, and I hope it encourages you to contribute. I would love to get more contributions from everyone here. I just want to reiterate, if you ever have any questions, just reach out to me and I'd be happy to chat with you. Is this the repo that runs the test in the Lobster repo? I'm not sure what the Lobster repo is, so Probably not. And thank you all for the great questions. I love questions.
Thank you very much, Justin. So just one quick round. Is there any other questions we want to ask Justin before we round up for the call? Good
Mercy, sorry, but
contribution.
I have one last question. Just one last one for Justin.
Okay.
Justin, so is there any rule of how the tests should run? For example, last week we're here and the guest tutor actually said, because we went and we're doing the issues and I was finding my own way of running the tests. And then when he came in, he corrected it. He said, your PR won't be considered if you don't use this particular way of running the tests. So is there a particular way these tests should be run? How, when, how does the test pass? What commands do we use to run the tests? Or it's just standard way?
There is a specific way in which you should run the test. I'll just type it here. So it's like make test. You could run just that and it would run everything. And as long as your new test is named appropriately, like where it begins with test and it has like the spec test thing above it, it would run that. But I would recommend doing make test k equals like test, whatever the name of your test is. And then if that passes and the test is written correctly, meaning just like it's a valid test case and it does what it should, then this should be valid.
The name of test means the file I'm running, right?
It would mean the name of the actual function. So
okay,
let me see if I can come up with an example real quick. So there's probably one call. So this is an example. So you would write something like this, and then you would say make test k equal sign this name.
Okay. Do you mind putting the test command in the chat so I get it?
Sure. Would it be useful just to say like, if you fork the repo and clone it, you would run this command, and this will pretty much show you everything that you can do. But the exact one that I ran was this one.
So which one is the better one? All of them?
I mean, if you want to run all the tests, you would just do make tests. I mean, that's a surefire way. Yeah, feel free to just like reach out to me. I'd be happy to chat with you on whatever service. And my Discord username is also J.
Where are you active the most? Telegram or Discord?
Honestly, everything. So Discord's fine.
Okay, thank you.
Yeah.
Okay, I think that will be all for today. Thank you, Justin. Thank you for the section and thank you for your time and the walkthrough you've given us. This is really helpful and we'll hope to extend by also contributing and then getting to know the Ethereum consensus spec much more better and utilizing the resources you shared to us. So that will be all for today. Thank you everyone for joining us. Also, don't forget to our section tomorrow, the same time, 1600 UTC. Bye, everybody. Bye, Justin.
Bye, everyone.
Take care.
Yep. Thanks for having me.
Bye, Justin. Take care.